vibes? Stay blessed or say less. It's your boy BLKFinesse. Yeah, y'all see the title. This one says, "What if we detonated all nuclear bombs in space at once?" I've never seen the video, but this is by ridddle. I'm actually intrigued because I like to learn stuff, but I don't think anything will blow up, considering that you need oxygen, right? Don't you need oxygen to blow stuff up in space?
Each of you probably knows that nuclear weapons are extremely dangerous. But this is true not only on land, but also underwater and in space. The consequences of explosions in each environment differ. While it's more or less clear what happens on Earth, in outer space, it's still a mystery. What do you think would happen if nuclear weapons were set off in space?
I don't think it'll do anything.
Not one charge, not 10, but all of them at once.
I don't think it'll do anything.
I decided to conduct this exact experiment. In fact, I'm not the first person who's thought of this. Similar experiments have already been performed, moreover, several times. One of them was Operation Argus, a series of covert U.S. nuclear weapons tests over the Atlantic Ocean. The explosions were carried out at different altitudes in August and September of 1958. The first two warheads managed to fly 170 kilometers, or 105.6 miles, and 310 kilometers, or 192.6 miles above the Earth.
High.
The third exploded at an altitude of 794 kilometers, or 493.4 miles.
Wow.
But the launched shells weren't powerful enough to cause any damage. All three W-25 nuclear warheads had the same blast power, only 1.5 kilotons each. However, Operation Starfish Prime turned out to be much more interesting. In this experiment, a series of charges were launched to great heights. The goal was to study how a nuclear explosion in outer space would react. As it turns out, scientists also found out what consequences such an explosion can have here on Earth. The very first test was conducted on June 20th, 1962.
Nuclear radiation?
A minute into the launch, everything was going according to plan. Then, a malfunction in the Thor launcher engine caused it to fail. For safety reasons, they destroyed the rocket and its warhead right there in the sky.
Good.
By that time, it had reached an altitude of between 9.1 and 10.7 kilometers. That's between 5.6 and 6.6 miles.
That's not that
Debris from the rocket and nuclear device landed on Johnston Atoll, the location of the launch. And as you may know, the consequences were serious. The results were radiation contamination of the whole launch area.
Yikes.
The second attempt at a launch was scheduled for July 9, 1962. This test was conducted on the same atoll in the Pacific Ocean. A new Thor rocket and new nuclear warhead set off for space once again. The 1.44 megaton W-49 thermonuclear charge reached an altitude of 400 kilometers, or 248.5 miles, which is, by the way, extremely high.
That's high as hell.
For comparison, the International Space Station sits at 417 kilometers, or 259
moves
miles
very
above
fast.
the Earth. Thankfully, at the time of this nuclear explosion, the ISS hadn't been created yet. So, how did this warhead react in space? Obviously, the explosion was completely different from what we'd ever seen on Earth. Here, we would normally see a familiar nuclear mushroom cloud, but at such great heights, there's practically no air, and thereby no radioactive cloud.
I'm saying,
What
you need
happened
oxygen.
instead was even cooler than the special effects in the movies. The high-altitude nuclear explosion created a powerful electromagnetic pulse, a short-term electromagnetic field. Such a pulse can disable electronic equipment, electrical appliances, and power lines. So, in Hawaii, within a radius of about 1,500 kilometers, or about 932 miles from the epicenter of the explosion, 300 street lamps and other electronic devices failed. In the same region, for about 7 minutes, an aurora-like glow was visible in the sky. But that's not all. The shell explosion affected spacecraft as well. The same electromagnetic pulse immediately disabled 3 satellites. The explosion also generated charged particles. Due to the high concentration of these particles, the solar panels and electronics of 7 other satellites were also damaged. In total, the explosion disabled 1/3 of the spacecraft in low orbit at the time.
So does it
All
really
these
explode?
tests taught us one very important lesson. Nuclear weapons are no joke. Such experiments can have absolutely devastating consequences. And what I've mentioned so far isn't even the worst of what could happen. That's why, in 1963, a special treaty was signed. It prohibits the testing of nuclear weapons on land, underwater, and in space. But let's imagine for a few minutes that this treaty doesn't exist. What would happen if every nuclear warhead on Earth was detonated in space at the same time?
I've been waiting for that answer.
The global nuclear arsenal is improving every year. Countries are creating increasingly powerful and destructive weapons. However, according to official figures, the total number is gradually declining. At the beginning of 2019, there were only 13,865 warheads in the world, while in 2018, there were 14,465 of them. This entire arsenal belongs to only 9 countries: the United States, Russia, Great Britain, France, China, India, Pakistan, North Korea, and presumably Israel. Russia and the United States own 90% of these warheads. The rest belong to the remaining countries.
Russia has more.
No one knows the exact number of nuclear weapons there are. Some remain hidden and others unaccounted for. So let's take an average number, 15,000. That's how many devices I'm going to launch into space. The power of modern nuclear warheads from strategic carriers ranges from 150 to 550 kilotons. But instead of calculating the exact power of each one, let's take an average. Suppose that every nuclear weapon launched into outer space creates an explosion with a power of 350 kilotons of TNT. Would this grandiose show of fireworks really be worth it? Definitely. However, aside from a light show, we'd also receive a strong electromagnetic pulse. Remember the Starfish Prime operation? The consequences of a 1.4 megaton warhead explosion knocked out 1/3 of the satellites in orbit and a slew of electrical equipment. Its wreckage led to the contamination of the whole launch area. Through simple calculations, I've determined the degree of devastation that we could expect from an explosion of 15,000 warheads. It turns out it's pretty sad. Such a number of shells would create an explosion with a capacity of 5,250 megatons. That's 3,750 times more power than the warhead launched from Johnston Atoll.
Is it brighter?
Can you imagine?
Is that what it looks
the
like?
nuclear devices didn't reach a high altitude before detonation. An explosion at 400 kilometers or 248.5 miles above the Earth would be enough to disable every active satellite. There are currently more than 2,000 in orbit. Remember that the ISS is located at this exact altitude. It's unlikely the crew would be able to survive. Firstly, all of its onboard electronics would stop working. Secondly, in airless space, nothing would slow the spread of gamma radiation. And what about the inhabitants of the Earth? An explosion with a capacity of 1.4 megatons influences electronics within a radius of 1,500 kilometers, or about 932 miles from the epicenter of the explosion. A 5,250 megaton shell then could disrupt all equipment within a radius of 5,625,000 kilometers. That's 3,495,213 miles. For comparison, the radius of our planet is 6,371 kilometers, or 3,958.7 miles. The resulting zone of destruction would be 883 times larger. Simply put, all of the Earth's electronic devices would suffer in such a large-scale explosion. But this isn't the worst that could happen. There's always the possibility of contaminated land from falling radioactive debris. You're probably thinking, what would happen if we launched warheads a little further into space? At the moment, almost all of our current launch vehicles are designed for flights to the low Earth orbit. The only exception is Saturn V, which participated in the moon landing. But launching such an apparatus costs quite a lot, and it's unlikely that anyone would be able to produce the necessary number of missiles. So, the bombardment of celestial bodies is a completely different story. I'll save.
Okay, so it seems like it only does electrical damage. It doesn't do any physical damage. Like, I'm not seeing anything physical. I'm thinking it's gonna be like a super huge explosion or something, and that part of the Earth, even though it's outer space, would damage it or something. But it just seems that with no air, it would just disintegrate and radiation would just start to spread. But it won't really do any physical damage. But comment, like, subscribe down below. Super Black Finesse, we out.